All right, class, this is lesson 3-6, compound inequalities. You're gonna learn how to solve and graph inequalities containing the word and to solve and graph inequalities containing the word or. It says write I if the math sentence is an inequality, write E if it's an equation. So if it has a less than sign or a greater than sign or less than or equal to or greater than or equal to, then it's an inequality. If it has an equal sign, then it's an equation. So that looks like that. Write the inequality symbol that matches each description: greater than, less than or equal to, greater than or equal to. Compound is a whole formed by a union of two or more parts. A compound inequality consists of two distinct inequalities joined by the word and or. Here's an example. You read 3 is less than x is less than 6 as x is less than 6 and greater than 3. So we're going to cross out the inequality that is not a compound inequality. That one is a single inequality, so it's that one. The other two are compound inequalities. In this inequality, we would read that as x is greater than 5 and x is less than or equal to 10. Or we could say just x is greater than 5 and less than or equal to 10. This inequality, we'd say x is less than -2 or x is greater than 3. The word and or are important. They have quite an important meaning. So we're going to draw a line from each description in column A to the inequality that describes it. All numbers less than 9 or greater than 5. So we need x is less than 9 or x is greater than 5. That would be this one. All numbers less than 9 and greater than 5. So they have to be less than 9 and greater than 5. That would be the and statement there. All numbers less than 5 and greater than 9. That would be that one. All numbers less than 5 or greater than 9. That would be that one. All right, like I said, we're going to learn to solve and graph inequalities containing the word and solve and graph inequalities containing the word or. So, what compound inequality represents each given phrase? All real numbers that are greater than 1 and less than 5. We can write this as two separate. To be greater than 1, that would look like that. And less than 5, so x, all the numbers have to be less than 5. And we can also combine that into one inequality where we have the lowest number first, and then x, and then the higher number. So we can see that x is between 1 and 5. So that's a compound inequality that represents that statement. B, all real numbers that are less than 10 or greater than 15. Whenever we use the word or, we can't combine it into one long inequality. We have to write them separate. So we'll use x to represent all the real numbers. They need to be less than 10 or greater than 15. So write a compound inequality to represent the phrase below: all real numbers that are greater than or equal to -4 and less than 6. Go ahead and try that. Pause the video and turn it back on to get the answers. Here's your answers. Notice that we have in order to be greater than -4 and less than 6, say I forgot the equal sign, not greater than or equal to -4 and less than or equal to -6. We have a closed circle on -4. and an open circle on 6, and it's the numbers in between. Whenever that happens, you could actually write this as one inequality. You could say -4 is less than or equal to x, which is less than 6. The solution of compound inequality involving and is any number that makes both inequalities true at the same time. All right, what are the solutions of this inequality? -2 is less than x plus 2 is less than or equal to 5. Really, we have two inequalities. We have x plus 2 is greater than -2, and x plus 2 is less than or equal to 5. So we really have two things to solve. If we solve the first inequality, we get x is greater than -4. And if we subtract 2 from the other side, we get x is less than or equal to 3. And then if we graph that, since our inequality does not include -4, I'm going to put an open circle at -4. It does include 3, so I'm going to put a solid dot at 3. And then the points that solve both of these are the points that are in between, so I'm going to highlight those numbers in between. And that's the graph. Now, some of you may have noticed that when I was solving it, that I subtracted 2 from both of them. So what we could really do here is we could just use the inequality, the whole inequality, to subtract 2 from both sides. And I'll show you what that would look like. We should get the right answer. So I could just, I want to subtract 2 so that I'm solving it for x. So if I subtract 2 there and subtract 2 there, I end up with -2 minus 2 is -4, is less than x, is less than or equal to 5 minus -2 is 3. And we get all the answers in one shot. You don't need to separate it into two inequalities doing it that way. Go ahead and try the answers to problem 2 and check back for the solutions. All right, here's your answers. Hope you were successful. Because the compound inequality includes less than, I'm going to circle it, it says underline, but I don't think I'll circle it. The graph of the compound inequality will include open dots. So the inequality will look like this. Fill these in 2, 4, 6, -2, -4, -6. We need to go from 2/3 to 6. 2/3 is, I'm going to estimate that to be about right there with open dot. 2/3. And then an open circle on 6, and then we need to shade in between for this and inequality. All right, problem 3, writing and solving a compound inequality. So here's the problem. To win the recycling contest, you must collect between 83 and 87 pop cans each week inclusive. The word inclusive means it can include the numbers 83 and 87 or be between those. Suppose you collected 82, 86, and 84 pop cans during the first 3 weeks of the competition. What are the possible numbers of pop cans you can collect during the fourth and final week in order to win the recycling contest? Let's let X be the number we collect the fourth week. So that means that X plus 82 46 plus 84 is the total I collected. And the total collected, divided by the number of weeks, which is 4, has to be between 83 and 87 inclusive. We can represent that with an inequality by showing that that number must be, 83 must be less than or equal to that number. And that total divided by 4 must be less than or equal to 87. So we can solve this. Let's simplify this as much as we can. So 83 is less than or equal to x plus, and we can combine these three numbers, and that's 252 divided by 4 is less than or equal to 87. Solve that. I'm going to multiply everything by 4. So I'm going to multiply this by 4, this by 4, and this by 4. And 4 times 83 is 332. That has to be less than or equal to x plus 252. And that has to be less than or equal to 348. And then if I subtract 252 from everything, I get my answers. So to win the contest, we have to collect from the last week somewhere between 80 and 96 pockets. All right, go ahead and try this problem, and I'll put the solution up for you. So here's the problem and the solution, and we can see that in order to get the grade you want, you need to score between 91 and 109. So I think it is possible you could get any score between 91 and 100, and that would give you the grade you want. All right. The last problem, solving compounding inequality involving OR. Actually, there's 2 more problems, so I'm going to stop this video now. This will be part 1, and then you should see part 2 also.